Hi, so we're going to talk about the general case for double rotation in AVL tree. So whenever we are asked to rebalance a AVL tree, the first thing we should do is to identify which node in the tree actually violates the AVL tree invariant. So given this tree, if we look at it, and again, all these little triangle just denote subtrees that we're not going to really touch. And we're going to assume for all these subtrees, they're going to have the same height. So if that were the case, then which node would violate the AVL tree invariant? Well, it would be node K3, right? If you, it's not K1 because both trees are the same height. It's not going to be node K2 because it's just off by one. And that's where K3 comes in. It's because the subtree on the left of K3 is two levels above what's on its right subtree. Okay, and now also we have to identify which case it is. So in this case, it is left right because for K3, the left subtree is higher, and then when we go down on to K2, the right subtree is higher. So this is the left-right case, and if you remember, in the left-right case, we cannot do a single rotation. What we have to do is that we'll have to first do a left rotation, and this is just the ordinary left rotation that we just talked about previously. So we'll bring up k to the root of this subtree that starts at k2. We'll bring up k1. Sorry, we'll bring up k1 to this subtree's root, and then we'll attach k2 to the left subtree of k1. So that's just a rotation, right? And obviously y still attached to k2 this way, x prime still attached to k1 as the right child. The only complication is, the subtree x, well, we can no longer put it on the left subtree of k1, but we can attach it to the right subtree of k2. Okay, so that's the first of the two rotations. And then the next rotation would just be um, the rotate to the right. Yes, there we go. And so if you look at this now, this is the edge we are going to be changing. K1 is going to come to the very top. K3 is going to be the right child of K1 now, right? It's a right rotation. Now, if most other things are the same, Z still attached to K3 as the right child. The only funky thing is kind of the X prime again. X prime, it cannot be the right child of K1 anymore. However, it's we can actually attach it to as the left child of K3 again because X prime is smaller than K3, just by the way, by its position in the tree. So most parts of this rotation should kind of make sense because all the nodes it's the same as the simple double rotation. And then if you look at both the subtree Y and Z, they are still in the same place as they were before, right? The only funky thing that is kind of a little strange is both X and X prime, they have new parents, and they are attached. And now let's just do a sanity check, right? Let's make sure X is still in the right place. So if we look at where X is before relative to K2, X is smaller than K2 because we get to X by going down on the right. I mean, sorry, X is bigger than K2 because we get to X by going down on the right side of K2. Now, if you look at where x ends up, well, x is still bigger than k2, so that's not a problem. And then also, x is smaller than k1 because it's on the left side of k1, and well, x is still on the left side of k1. So we're good as far as x goes, and you should kind of do the same check for x prime and make sure x prime is in the right place relative to both k1 and k3. All right, and you know what I'm going to ask you to do next is, that's the general case for double rotation in one direction, and then there's a mirror rotation, mirror double rotation in the other direction. So please do try to work that out. And here is what I have for that. So please do verify yours against mine. Hopefully I get it right, but if I didn't, if I make any mistakes, please do let me know. But I'm pretty sure you understand by now. I am pretty tired of drawing circles and triangles.